Okay, what we have to do is a little example here on multi-factor productivity. It's from chapter 1, question 8 in the problem section of the book on page 26. We have to calculate the labor and multi-factor productivity for two processes which produce two components, A and B. So first we'll do process alpha. So alpha, and some information that we need is we have our output in units, but we need the dollar figure for our output. So all we're going to do is take the given output dollars in output dollars in the problem, multiply it by the number of units, sum them together, and we'll get our total. So that essentially boils down to 50 units at $175 a unit. 175, not 75. And add in our 60 units at 140 per unit, and our output in dollars is going to be equal to 17,150. That's right. So that's our total output for both products or both components. Our total labor, all we do is just add them together. So it's just 1,200 and 1,400, so 2,600. $2,600. And our total material costs is going to be 2,500 and 3,000, so it's $5,500. And then we're given our overhead for A from the problem is $6,000. So we'll do our labor productivity first. So that is simply going to be equal to our total output in dollars, which is 17,150, divided by our total labor cost, which is $2,600. And the ratio for that is going to be 6.596. I want to point out one little thing. I guess it's a sticking point. In the book, they have labor productivity has a dollar value, productivity is a ratio, and does not have any dollar amount assigned to it. So then we'll work out the multi-factor productivity, and that's just going to be our 17,500 divided by the sum of all of our costs. So our labor is going to be 2,600, materials is 5,500, and our overhead is 6,000. And that's going to give us 1.216. Okay, so now let's work it out for process beta. It's just the same math. We're going to have 30 units at 175 a unit, and 80 units at 140 a unit, and that's going to give us a total of our output in dollars 16,450. So then for beta, our total labor costs is going to be 3,000, so it's just 1,000 and the 2,000, and then our materials is going to be 4,900, and then our overhead is given. Our total overhead is given, and that's 5,000. So our labor productivity, again, the division, so it's $16,450 divided by our cost of labor, which is $3,000, and that's going to be equal to 5.483. So then the multi-factor, that's again just going to be our $16,450 of our output value, and then we're going to just divide that by the sum of all of the costs. So our labor is going to cost 3,000, our materials cost 4,900, and our overhead is 5,000, and plug that all into the calculator, and that's going to be equal to 1.275. Okay, just want to quickly talk about the two different numbers and what they mean. So when we look at labor productivity, we can see right here that process alpha has a higher value. So for labor productivity, just for pure labor, process alpha is more productive. I believe the answer key works out by how much, but that's really what you want to do, is compare the numbers between the processes, and the higher number is more productive. We can see that down below, when multi-factor is taken into consideration, because of the lower overhead primarily, we can see that in fact process beta is more productive. So which way do you how should you interpret this, and which one would be a better process to use? In supplement A, there's a lot of decision-making tools talked about, and that's really what you'd be looking at using. Labor productivity is a more valid measure when labor makes up a larger percentage of the total cost. So if your materials were costing, in this case, $50, as opposed to the higher dollar value that's there now, labor productivity might be a better value. It would show up in the overall weighting anyway, but in the case we have here now, the multi-factor productivity, because the material and the overhead values are so high relative to the labor, that's probably a better decision-making tool to decide which process would be better.